right? So this was for functions. Now, if I go back up here, I told you that x is all real values, and I told you that this is what's called the domain. But I didn't but I didn't dive deeper into it. So this is what's called the domain, and this is what I will talk right now about. Right? So let's talk about domain and range. Let me zoom in a bit. Right? So domain and range. Okay. So let's say, please draw a straight line. Better. So let's say there's some graph y equals 2x, right? Y equals 2x plus 3, right? And if I do not restrict the input I give to it, right? Let's say this is the x-axis, and let's say that inputs are all real values. What this means is that for any x on the number line, for any value, there will be some output, right? So if I were to draw a number line over here, these are your inputs: 0, 1, 2, -1, right? And this is your output: 0, right? And this goes through the function. So for example, if I input 1 into it, 1 goes to 5. If I input 2 into it, 2 goes to 7. If I input 0 into it, 0 goes to 3. Right? So if I do not restrict the number of inputs I give to it, there will always be some more outputs, and the graph will keep on stretching above and below. However, if I told you that, let's say that the domain of this function d is somewhere between, let's say, 1 to 4 inclusive, right? And this is just a formal way of writing 1 and 4, right? 1 to 4, because you can break this up into two parts, and what you're saying is that x is less than equal to 1 and x is greater than equal to 4. So on a number line, this looks something like this, all the values between 1 and 4, right? And whenever you're describing a range, you tell the extreme values, right? You tell the lower limit and the upper limit. So for example, if there's a roller coaster ride, and I want to restrict the ages from 14 to 30 only inclusive, right? So I want ages A to be greater than equal to 14, and I want ages to be less than equal to 30. So I can write this as 14 is less than equal to A is less than equal to 30. And I'm defining the upper and lower limit, right? I'm telling you the extreme values, and this is how you tell ranges, right? So what domain really is, it is the ranges of input that the function can take. So here the function can take all the values from 1 to 4. So at 1, at when x is 1, the output would be 5. When x is 4, the output would be 2 times 4, 8 plus 3, 11, right? So if I'm restricting my domain to only these values of x, my graph will also be restricted, and it will look something like this, right? It will look something like this, just the red part, right? And what ranges are just the range of values of the outputs, right? So here the lowest value you get is 5 and the maximum value you get is 11. So your range of this function for this certain domain would be 5 is less than equal to f of x, which is just y at the outputs, which is less than equal to 11. Just saying that the ranges of output you get are between the values 5 to 11 for when you restrict the domain from 1 to 4, right? That's the concept of domain and range, and maybe it won't seem that useful or relevant right now because we haven't done quadratics. But when we come to quadratics, you'll probably see why it's helpful, why we need to do it in some cases. All right, so this is done. And the next bit I would like to jump to is actually inverses, right? Inverses. So what are inverses? Well, inverses, inverting something, doing the opposite, right? So an inverse function is similar. An inverse function f inverse of x basically undoes undoes what a function has already done, right? And let me explain what I mean by that. So let's say this is some input, right? Okay, some output. So let's say there was some input 2, and after going through a function f of x, it became 5, right? You took 2, you inserted into f of x, and it gave you 5. Now, what f inverse of x will do, it will take this 5 and it will give you back 2. It will take this 5 and it will give you back 2. So let's note something else, x comma y, right? Here the input x, the x values were the input. So here the input was 2 and the output it gave was 5. Here you're taking 5 as the input, right? You're inputting 5 into the inverse function. So 5 is actually the input and 2 is your output. You'll notice that the inputs and the outputs have swapped their places. And this is what happens in an inverse. If your function, if y equals fx has the coordinates x comma y, then f inverse will have the coordinates y comma x. And this is the reason why, because you're taking the output, you're inputting it into the function inverse function, and it is giving you back the input. Right, what this looks in a number line. So let's say these are your inputs, right? Let me draw with a different color. These, let's call it f of x, right? This is you inputted f of you inputted these values into f of x, and okay, let's just call this first, and let's call this second, right? So I have a bunch of inputs, let's say 0, 1, 2, and I am taking these inputs, I am inserting it into f of x, right? So 1 goes to 3, sorry, 0 goes to 3, 1 goes to 5, 2 goes to 7. All right. Now, if I put these values in f inverse, what they will do is they will have the opposite effect. They will take 7 and they will give me back 2. They will take 5, they will give me back 1. They will take 3, they will give me back 0. Right? This is the effect of f inverse of x. Right?